implementation details on how a new node's created, how to update the node and the provider implementation, and kind of the different parameters that get passed through and what talks to the Kubernetes API server and things like that. So if you guys want to go ahead and just read it through, it should only take a couple minutes and then we can talk about it. Cool. Has everyone gotten through it? Oh, that's what the connector looks like when it's installed in your cluster, if you guys want to know. But I'm going to stop sharing the screen. Okay. Is everyone good? Okay. Yeah. Awesome. I think I accidentally muted everyone so I couldn't hear anything, but cool. So any questions for how it's implemented? The code's actually fairly easy to read, thankfully. So going through the code isn't too bad to understand what's going on either.
Are we unmuted? We're unmuted. So one of my biggest concerns of the virtual kubelet model is dealing with all the plugin points on the node. So things like storage, networking, and monitoring, logging, daemon sets, all those things. Have you thought at all about how to handle those in this model?
That's kind of why we're coming into this group too, in this forum, because we haven't thought about everything. So right now, the way that implementation is working, and I'll just be completely honest, the way we're doing it is whenever a new feature comes through for ACI, so Azure Container Instances, for example, we just got support for DNS name labels. Like once that comes through, we directly put it into virtual kubelet. So there's not a lot of like futuristic design happening yet. Networking is a huge one because I'm not 100% sure how pods that are in your cluster are going to talk to pods that are in a different service, like in Hyperservice or Azure Service or whatever. And then there's another question for what's a provider even? Like what should we accept? What should be in the repository? What shouldn't? So there's a lot of those kinds of questions right now that we need to work through. So that's where, like, once we come towards networking, like, how me and others can help drive a spec and then bring it to you guys and be like, this is kind of what we're thinking for the design. And then hopefully talk through it, because I think we'll need that. But this is just like a starting point. Yeah, because I don't even know how like daemon sets would work.
Do daemon sets have to work in this context?
I don't think so. We do have a concept of it's possible to install multiple connectors for different configurations. So, and I'm just going to use ACI as an example because it's the one that I work most closely with. But for example, with ACI, you have to put in like resource constraints that are congruent to what we have within our service itself. So you could have different connectors that have different constraints or specs like that. You could also have a connector that deploys into different regions. So you could have one connector that deploys out into East US. You could have another one that deploys out into West US. And you can start to get like multiple connectors in a cluster. And kind of the all-up scenario is, what if you just don't have VMs in your cluster at all? You don't have any agent VMs and you're just running off of containers, basically. That's kind of the goal state, making sure that an entire service or entire application could just work standalone within a service deployed by virtual kubelet. So
I have kind of a high-level question. How do you see this as being different from like the other multi-cluster efforts that are going on in Kubernetes? Is this just about managing? Like,
this is more about management. So it's more about the fact that you don't have to manage the underlying VM infrastructure. That we abstract a layer on top of that. Sorry, there's a dog right next to me. Babysitting it for a coworker. Come on, it's okay. So yeah, basically being able to just abstract above like the VM infrastructure so people don't have to see that or deal with it is the way that we're looking at it. So it is different. But like the cluster configurations, that's where it can become a little bit confusing. And Robbie's joined. Robbie, hi.
Hello.
Hi. Okay, everyone, this is Robbie. So he's one of the main maintainers of the project. So I want to introduce him because I think he'll be able to come to every weekly meeting, and he has more of like technical details of what's going on. He understands that. Do you want to ask your question again, and then maybe Robbie can answer too?
Sure. I guess what I'm trying to get at is what or how this is different and what problems it solves in terms of there are currently efforts in the community to be able to essentially create tools to manage multiple clusters. And I'm just curious what this model of sort of a cluster as a node offers that's different or better, or what the advantages are of the approach that you've taken.
Okay, Robbie, do you want to take a stab and then I can add details about, because I think basically what we're getting at is like it's containers as a service, right? So Robbie, you can.
Basically, we are thinking about solve the problem that do not need to maintain their infrastructure, their VMs, but to use the ACI or other providers as alternative to run their pods. It's not like the multi-cluster federation, because it's not necessary that it's also a Kubernetes cluster. It can be any container service.
So just out of curiosity, if the idea is that you don't want your users to have to manage or see nodes, couldn't you just...
Yeah, that's the ultimate goal. Currently, we still rely on one node, one VM to run
do they need to see any node in general? I guess what I'm wondering is, like, if that's the goal, then like, is the desired end state that just people get nodes is an RBAC deny operation for your end users? Or is it really you want kube control get nodes to show one virtual node? And then why does the user...
we want to, the ultimate goal is that you only have one virtual kubelet.
But that's what you want, and you want your users to see that?
They still follow the Kubernetes node pod allocation or pod scheduling.
I guess
so they need to
follow those
pod on this virtual kubelet node, and then it will be to the provider.
I don't know how you follow Kubernetes scheduling, all those kind of things, because the scheduling you need to have the total capacity allocatable, and then you have the coming request, right, against that, and then you have the tend against that. I'm not sure this one is how you're going to follow Kubernetes controlling model, scheduling model, and any model.
Can I answer that? Because like I had to deal with this with what I did. You could it basically becomes an infinite resource node. Like when Burns demoed ACS in the general meeting, I asked about like how it was implemented, and he said basically they are running the individual containers or the pods within individual VMs. So basically, it doesn't have. You can think of it as a node which has no resource limitations.
There's a lot of ways you could satisfy this model, though, right? Like you're basically describing the virtual kubelet as like a meta node or an auto cloud autoscaler, and like you could go and dynamically provision a virtual node or a fake node in the Kubernetes API construct itself that has a max pod constraint of 1 and is sized exactly to meet a pod size request. Yes. And like from the user standpoint, you still see a node. What makes me concerned about some of this effort, and I have not looked deeply at it, it's just like foundational things I feel like that don't mean what we think they mean, just introduce confusion or user error like months down the line. So like trying to make something that is a node not be a node feels like a little concerning versus like another model where you could have something that fulfills like the vision of a virtual kubelet, but it presents literal node resources, the kube control plane that might have like scheduling constraints imposed on them. So you might only support one pod. You might support only a specific set of taints so that certain pods only land on them. They might have resources that align to the one pod you want to fit, but trying to make a node look like one thing and infinite things just feels difficult to me. And I'm wondering what everyone else's take on that is.
Yeah.
Actually, I think the provider decide to report how to report these information, the node capacity and like the available capacity. And currently, we did report the capacity for the ACI, but it's not a requirement for all the stuff, all the providers right now.
To frame Derek's point slightly differently, the node is designed to be a machine manager, and we have this cluster control plane for managing a cluster. This is sort of turning the node into a mini cluster manager, and why not just let the cluster control plane do what it does best and make each pod a node essentially.
One can make the same argument for any sort of VM-based CRI implementation, like Kata containers, that like you are turning the node, like the kubelet, the node, into its own cluster manager. In this case, these are VMs running on the node itself.
I see a distinction in that the Kata container does not report back as a new node, and
yeah. I see the huge differentiator here. Yeah, they didn't really act. They are like the node management, and they are just management one part. They are not fake. There is the new node join that cluster, and they are not. And also on the node, when we stand off those kind of things, we still need the Kubernetes, the node manager, to report back cluster manager to here it is the usage, all those kind of things. And so it's quite different. Each one have their own role and acting there as themselves. Instead of this one, we are kind of like the master, whole master component is doing nothing, and need the Kubernetes become to cluster management. That's a huge change.
So when I implemented this last year, like when I demoed it to you guys, like with what I called Infernetes, like I implemented it as a CRI implementation. So you had a real node, but instead of speaking to the Docker shim CRI or the Rocketlet, you spoke to my CRI, which would then, if a pod got scheduled to my Infernetes node, I would then provision an AWS or GCP or Azure VM and run the pod, the container, or all the containers that belong to the pod within that VM that I instantiated. And when kubelet said, remove this pod, I would shut down the VM. And it worked basically totally with the CRI implementation. So like, I guess I'm confused why like you like there's like pushback to the virtual kubelet in terms of like it is a node. It's just a node that's not running things directly on it. It's running it within sort of the infrastructure provided by your cloud provider.
to me the pushback is like all the things that become difficult to manage. And I don't know, like, if we want to enumerate them all now, but like volumes, monitoring, we could go through a node conditions. We can go through like a big list, but like everything that like the node controller watches, daemon sets we touched on. I just think it's very possible that Robbie and Shia, you're further along in thinking on this, but it's not something I've digested well enough to like.
So I will say that volumes are difficult. Volumes as they are done today don't translate necessarily easily to this model. Especially the way I did it, the way Microsoft is doing it, it's possible they can translate better, especially because I was using just a regular kubelet with CRI. So things like attaches would be done like if you were using an EBS volume, it would tell kubelet to do the attach. Like that CRI has no knowledge of this. So it fell down for me, but like if you have sort of your own full kubelet doing these things, like you can say, oh, you want me to attach volume X for pod Y, or because it'll eventually be mounted for pod Y, I could basically proxy this. The issue is that you can end up with sort of race conditions because attach is used as a locking mechanism to prevent things from trying to get both, and as a scheduling, I guess, barrier. But yes, I do agree that certain things like volumes could be a problem. And I think, but without sort of moving it along, you can't actually think of how to solve them, or like maybe like like you lose, if you want to use virtual kubelet type things, it's not sort of like, I would say it shouldn't necessarily be viewed as a replacement for nodes, but as complementary, like it's a complementary function to nodes as well. Like, and it does something different that you can't do with regular nodes.
What the director suggests shouldn't satisfy your use cases, or anything's not satisfy use cases. And what he suggests, just using the existing cluster control plan and limited. So instead to need the Kubernetes do those class level of the operation. And is there anything missing there?
To me, the only gap you'd run into is if you want to drive really dense clusters, then you would have the appearance of like a very large number of nodes that need to drive checkpointing operations back to the control plane. So like, I don't know what the scale limits you were trying to push with the virtual kubelet itself, but like if you're trying to drive like 1,000 pods behind a virtual kubelet interface, if you did manifest those all as unique nodes, then you've kind of overwhelmed our current scaling characteristics. So I could see the tension there, but
I agree that that would be one of the big challenges to trying to scale up with the per one pod per node model. But I think that that there are issues that could be solved there, and any progress towards making that situation better would benefit the whole of Kubernetes, right? We would solve scaling problems for the non-one pod per node case. It would generally improve performance, versus this approach, which is kind of like putting that effort into implementing a lot of the kubelet, and there will kind of always be this feature gap and like kind of trying to play catch up with.
And also, Derek, I do see that they still have like each virtual Kubernetes in the proposal. They also have the Kubernetes clients to talk to the API server directly. So that part actually confused me.
okay.
So after you start that one, actually each virtual Kubernetes host that single pod still need to talk to the API server. At least from that document I read so far, it is the one cases. So then still, we may end up some scalability issue there.
Yeah, on a human level, I mean, I have trouble just keeping track of how the kubelet works. To try to imagine how I would obfuscate how it works at a different scale. Like I don't want to be the one that's blocking this or challenging it more. I'm just I get nervous when things don't look like what they are.
I also have a question. So, I mean, it seems like all of this could be done unilaterally outside Kubernetes. What needs to be done in the code base? I mean, I guess why. I mean, it seems like someone could just go do this. What needs to happen inside Kubernetes, I guess, and then like, does this pin us into like a stable kubelet API, and are we gonna have to version that and things now because we have multiple kubelets and people don't want to rewrite their virtual kubelets every time we bump Kubernetes?
Which is why I would recommend it be done as a CRI implementation and work via like the CRI API, because that is the stable API, and like it doesn't make restrictions on the rest of Kubernetes.
This is Mike. I agree with this. That CRI should be, also the host for virtual machines. But we haven't really got that far along in the API on CRI for for VMs. Is this the result? Is virtual kubelet the result of CRI not handling virtual machines in a first class way? Why are we going this way instead of CRI?
So I did implement it with, like, if you look, like, I've shared it before. I'll share the link again. Like, it's not up to date. It's the last commit I did to it was 1.7 time frame. But like, you can do this via the CRI, though there are hacks. Like, I had to hack. It's a bit hackish to get it done. So I guess my point would be, like, since Microsoft is putting more effort into this, it would be perhaps useful for them to look at the CRI implementation, like the CRI API, and see what's lacking in terms of trying to implement virtual kubelet from the CRI and report back about that.
Is there a desired end state that around, like, is the virtual kubelet going to stay out of the Kubernetes organization, or are we looking to make it like an associated repo, or what is the project's relationship to Kube itself that the maintainers would like to see?
In the future, we were thinking that this would be part of Kubernetes itself. Short term, I don't think it will be, just from what's going on with like adding new projects to the repo or incubator and stuff. But
there is a model for that now, right? So like, there's the concepts of associated repos,
okay,
big sponsored repos, and then core repos. So like, to scope this discussion, I can't tell like if the project maintainers are asking Sig Node to like sponsor this work, and I don't know, like, as a group, if that's something people want to do or not. We probably have to have a deeper discussion on that. But like, generally speaking, to go back to Seth's question, like, should we be thinking about how you want to change Kube itself to support your use case, and like, if those things were identified, maybe that would help scope future discussion. And then you guys, iterate and evolve, improve the model out within the confines of that project, and then if it, then assess again.
Yeah, we can come back. So, basically, are you guys missing like the customer use case right now?
I guess.
Or just like use cases in general?
I guess from speaking for like the customers that Red Hat is representing right now, I have not heard a strong outcry for supporting virtual kubelets that like makes
the reason
that a higher priority than other priorities we would tackle on the SIG. I can't speak for people.
Okay. I understand the SIG standpoint, because I also like don't know from a customer standpoint like what is going up in a Sig Node and what's more important. But from a virtual kubelet standpoint, and why it's being implemented and why we really think it's important, is the fact that people now don't have to manage VMs in their cluster. And that's the way that we're thinking of it. And like, they don't have to do upgrades or updates or patching or whatever for their agent nodes, because that's all hidden from them. All they see are their pods, and that's all they have to deal with.
Hey, Rhea.
Yeah.
Yeah, I'm Harry.
Hi, Harry.
Yeah, hi. Yeah, it's actually very interesting to see if virtual Kubernetes can be a Kubernetes incubator project, but it's feeling like it's more suitable for a SIG architecture to sponsor instead of Sig Node. Yeah, that's my thinking. Which, I'm feeling like virtual Kubernetes not in the scope of Sig Node, which focus more on CI stuff, but it's more like related to the SIG architecture. Yeah, that's my personal
thinking. So SIG architecture, people talk to me and suggest they talk to the node. If the node, because the first start it is the change node, and and also change Kubernetes. So they think about wanting SIG node community start the first to see this how we potential collaboration or collaboration. And if the SIG node think about this is not the SIG node want to sponsor, then maybe the virtual Kubernetes project have to look into some other sponsorship. here.
Okay, I see. Yeah, that makes sense.
And I want to answer your earlier question. And you mentioned that, yes, when we work on the CRI, I remember your demo. And I even remember you came to our site and gave a demo. When we start Sig Node CRI, we do talk about some potential of the CRI could be the remote CRI. I think in one of the email to community, I also mentioned that, but it's not. There's a lot of tons of the problem, and so we didn't make any progress on that one. And so back to the problem. The problem it is when you do demo, we encourage that one. It is because Kubernetes is open source project. We want to encourage of innovation. You ask why we push back this time. Here's the reason, because when we talk about this one, it is become to the a community or group, SIG group, sponsor project. Then we need to think about, is the real use cases back up there? Is the real production use cases? And is the real user waiting for this solution? And is this aligned with Kubernetes API, today's concept and the design and the architecture? So that's why we have to think about this one. So it's not really pushback. We just question because we didn't clearly see the use cases. And we do understand there's maybe the potential use case, but the use cases, is that strong enough? Like the people mentioned that not manage VM. Can we fix that problem through some other way instead? We have to change the whole architecture design, change the control plan, and change cluster API and change node API to fit that model. And there's the many things to management VM is that Kubernetes first design philosophy here. So a lot of things need to think. It's not like that we try to push back. It's just we need to ask ourselves those questions.
So it wasn't so much about, like, my project was more of a toy project. It was more so comparing it to sort of Kata containers. Like, to me, the use case that I was thinking about back then, which I still think has value, is the fact that it goes to the, I guess, the discussions that Tim has been leading the past couple of weeks in terms of security, that when we run containers pods today, we are multiplexing many on a single node. And this is, you are at the whim of the security of the machine. And if I trust to some extent Microsoft, Google, Amazon et al. To maintain the security of their hypervisor much more than I can do it myself, even on a node of my own. And so by being able to run individual pods within individual VMs that are protected by sort of the hypervisor of the cloud, that are isolated, like, to me, I have sort of this higher level of trust. Like, that was one of the use cases I was dealing with back then, and I still think it has value.
Another use case for us is scaling really fast. So we have, the way that ACI works, we have all these warm pools of clusters that are running Kubernetes in the backend. But basically, we're able to now, with virtual kubelet, scale out our clusters super fast into ACI or other pods as a service providers. And that's another use case where people don't have to get into the nitty-gritty about capacity management for their clusters. They don't have to plan for an unpredictable workload, but instead they can just spin out in 30 seconds or whatever into as many pods as they could imagine without having to deal with placing the VMs, which Kubernetes helps you with, but it doesn't help you with the fact that you need to scale up your VM. It doesn't, you get what I'm saying? This would allow people to scale out really fast.
In the architecture you have, to me, like, the delta is how quickly can you bring a node to a kube cluster versus how quickly can you spawn your container on one of these warm pools. So, like, if you have, like, node pools that are already warmed, can they just dynamically shift and align which cluster they serve, or are you trying to have these node pools serve many clusters?
Like, so, I mean, we basically provision out pods, which are container instances. So they go out as fast as we can pull down the image, they're given to the customer.
So basically, at the end of the day, you're running a pod on another cluster that's not visible to the customer.
Yeah, exactly. Yep.
Okay.
Also, I think, Ria, a point would be is that you're only paying for the exact resources needed for the VM that you are using, as opposed to like if a person himself would scale this out, like himself, or have sort of warm nodes waiting in the wings to be used, they would be paying that cost 24/7 for when it's not needed. Is that correct?
Yep, exactly. You only pay for execution time.
Is everyone on an isolated VM? Or are all the pods landing on, like?
It could be. In the future, we'll have multi-tenancy. So they will be isolated through clear Kata containers and like Hyper-V Windows. But
Okay. I guess I would encourage you to continue exploring the space. I personally am not sure I can contribute to the space. Maybe others are, and we should understand within the community what people's perspectives are. But it's an interesting model.
If we wanted to move forward with this as a sponsored project, it seems like the first step would be to develop a formal specification for the kubelet and all of the kubelet's behavior, which is not something we currently have. So, iterating over every feature and really getting down into the details of how those are expected to work. And if there are optional features, then declaring those as so, but like really defining what the expectations of a node in the cluster is. Alternatively, building in more formalized API or interfaces and extension points like the CRI, and then building this as an extension within the kubelet and sharing that code.
yeah, that makes sense. We can go back and kind of build out the specifications for everything for what we believe we need to add in the features and the APIs and stuff. Robbie, do you have any additional input for where to go and how to help Sig Node understand what we're trying to do?
I think this is a good point. We need a formal specification. I think currently we have some documents in the repo describe our interfaces, and yes, we need to explore the CRI APIs to see how to collaborate to that.
I don't think we're talking about the CRI specifically. I think we're talking about like a node has expected behavior when you do certain things, like assign a pod to it. So I think we're talking about essentially everything that a node does. Let's try and harden out what it does and how it does it.
Even at a practical level, like if I want to provide a config map that says how my node behaves, does that align with the virtual kubelet concept? Am I expected to be, when I'm managing a cluster with a virtual kubelet, is the virtual kubelet the only node in that cluster, or are these workloads mixed with traditional VM?
All right, thank you. So currently, virtual kubelet is not necessary to be the only node to the cluster. It's just an alternative. And for example, like config map or secret, all this information, the virtual kubelet will fetch from the Kubernetes, from the API server, and send it to the provider. And the provider will decide how to use that. Either, for example, like the ACI translates all them into a secret. Actually, it's protected settings in the ACI. and send it to the provider securely.
Could my pod write to disk and fill up local disk, and then how is that?
Local disk currently doesn't support because it's crossed the boundary. So we only support the public shared, like the file shares or secret
Is the
volume.
copy on write layer for my container read only, or could I exhaust everything I'd want to write to on my copy on write layer and then induce like local disk pressure, and then just how all these things then like come back up to the cluster control plane? I think these are the tension points that Tim, myself, Don, and probably David and Seth are raising. But and that's where having a formalized spec, because it'd probably be great if we wrote down how the qubit works today, but it could be that we're running into like discovery problems where maybe you hadn't yet run into these issues yet.
That's a good point.
Yeah, and also my background also means that the Kubernetes spec also need to include the supporting the CLI implementation. So what kind of things the CLI you need to change? When you start this one, who is your executor, right? So are you think about the CLI, and then what kind of the CLI you want to change? Also, we have to include that.
Currently, we don't see any requirement on the CLI change because it's not calling any CLI API. All the communication is go through the API server. So the virtual Kubernetes fetch which pod is assigned to the node, which pod is assigned to the virtual node, and then spawn it up in the provider and send it back the pod status and update the node status.
So today, actually, in the Kubernetes, and there's besides Kubernetes could talk to the API server, or also have the node problem detector talk of the API server. So are you going to have those kind of the daemon set there?
Right now, no.
Are you going to have the Kubernetes proxy there? Or you are just design other node balancer to handle all those kind of the routing?
We don't have kubeproxy implemented.
So when I implemented it, I actually ran kubeproxy within the VM, and it worked great.
Yeah, that's something we haven't implemented kubeproxy in virtual kubelet yet. Robbie, correct me if I'm wrong.
So some people already have the pre-spin up of the virtual Kubernetes nodes and the standby, and already have the Kubernetes, and also already have the kubeproxy. Is that true?
That's correct.
Just for my own, are you targeting particular classes of workloads? Like, are you targeting batch processing jobs that just want to use excess compute like at a low spot price of some kind? Or are you tracking like long running web workloads? Like what is?
Yeah, right now it's definitely batch. Definitely batch workloads using excess hardware, like things just like that. In the future, we do want to make sure we can support long running services. In the future, we want this to almost like, if someone doesn't want to have to manage their agent nodes, they should be able to also just use pods within their cluster, virtual pods or virtual kubelets, basically. So that's right now it's targeted as unpredictable burst workloads. And it could be like that for a while. I mean, you could just be running all your long running services on your agents in your cluster and then burst out through virtual kubelet when you need to. So that could definitely be a use case that's just forever goes. It really depends on the customer, but we're finding that some customers want a completely managed cluster and some customers just want to be able to burst when they can.
So are there any other things we want to discuss on this topic? I guess it'd be good to get more details, I guess, and then probably be good to understand like if there's a formalized goal of having the SIG sponsored of some kind, like we should probably talk through what that process would look like. But are there any other topics for like today's discussion that we want to cover?
I would just like to add one thing, because there's been a lot of, I guess, talk that people, I guess, are confused in things like sort of daemon sets or like.
We cannot hear you clearly.
Can you hear me better?
Yes.
Okay, sorry. I have a hackish microphone set up. There's been a I guess confusion people have that they don't necessarily see how certain Kubernetes concepts necessarily easily fit in, such as daemon sets being a prime example. But the thing I would point out to think about is that this could apply to if you're dealing with heterogeneous clusters, right? If you had Docker, a normal Docker shim node and a Windows node all in the same cluster, you're not going to run a daemon set across the whole cluster. So it's really viewing this as sort of a heterogeneous node that, yeah, you might be running things in a daemon set or other ways, but they just don't apply to this type of virtual node. And it's thinking in terms of, I guess when we approach this, we should think of it in terms of heterogeneity, because I think in practice, Kubernetes is going to have to move in that direction. It's been today, till I guess recently, very homogeneous clusters, but thinking.
I don't think that that's true. I think the mental leap for me is a node that wants to present two container runtimes at the same time, or a node that wants to present two OSs at the same time. You can support heterogeneous clusters just fine. And yes, users have to learn to target their daemon sets appropriately to the cluster, but you haven't foundationally changed the meaning of the node primitive. And this is basically challenging us to change the meaning of the node primitive.
Yes, I agree. And also, I know earlier I believe people brought up the daemon side. It's not mean every daemon side. They just actually mean the functionality, those basic functionality represented by those daemon side. For example, you don't need a kube proxy. It's not all the Kubernetes cluster need a kube proxy, but those kind of the routing functionality are how you are going to get. So that's why we ask, and also and if the node have the problem, how are you going to report that node problem? Is there any way you are going to report those node conditions? We just want to understand those kind of things. So that's kind of the we try to define our node spec for last couple years, and how we manage the resource, how we manage the node condition, and if there's a problem, how we diagnose those issues, and provide reliable support to the customer. So that's kind of things we try to understand here.
And this is a little bit what I was getting at with the talking about a formal specification. You said maybe we could say that daemon sets, you don't expect to run daemon sets on a virtual node. Right now, the expectation is that daemon sets run on every node in the cluster. And so I think we need to decide whether that's a feature that is acceptable to break in a conformant Kubernetes environment, I guess.
But they run on every node that matches the label selector, right?
Yeah.
Yes. And another thing it is the first my reaction when I saw this today's proposal. I would just think about, okay, we have the conformance test, and don't even talk about the cluster level of the conform test, and just node level conform test. How are we going to validate those things? And so we have the node level conform test, and I believe a lot of it is going to be broken. Right? So how we are going to validate, to provide conform for this one? So that's why I think that I just like what Tim said. We need a formal virtual Kubernetes spec here, and then we understand this one, what it require change, what it is resume, and then we are going to come back to discuss this one. And Derek, I don't know what's the new process for the steer committee to design for the per SIG group sponsor project, how we are going to go through process. So, but at least I think we need to see the virtual Kubernetes spec, right? Then we can discuss, come to the community meeting and discuss this one. Then we can decide it.
Yeah, so I think, Dawn, we need to schedule time to actually get the Sig Node governance charter established. And I think out of that, we should decide like what's the criteria that we would sponsor. And I'm sorry, Dawn, but
you definitely saw my face.
Yeah, I saw your face, and the good news is your colleague Phil put together a nice document that we could emulate and take out what we do or don't want. But I think in order for us to like sponsor something, like we just need to have like clear and fair criteria for how we would make a decision here. So like it's transparent and we can use it as a rubric going forward. But like I think the clear spec and then having our individual charter identified would probably be prereqs to then figure out what to do with this project moving forward. And maybe Dawn, we should set a goal for Sig Node to get our charter done in the next like 4 weeks or so.
Sure. Mm.
And I'd be happy to talk through what the steering committee has done with that, but maybe Dawn, you and I can put together a rough draft and then share it in a future SIG meeting.
Sure.
Thanks. We'll put together that formal spec. Come back to you guys. Thanks a lot.
Thanks for come to discuss virtual Kubernetes. Actually, it's very hot topic nowadays.
So the only thing I know, I apologize, Dawn. I tried to get material together today for Tim to give feedback on the sidecar elevated privileges. There's a rather spirited internal email thread here at Red Hat giving all of their perspectives on the matter. I imagine every company had a similar one. And so I will try to get that done for tomorrow, and then maybe next week we could visit that to get other perspectives. But I wouldn't say that anything that we've found is too groundbreaking. It's more like the tension is, yes, every case where it's been called out, you could ask the component that requires it to be rewritten to not require it. But then it's a matter of like, is that actually viable or not? But there's about 6 or 7 use cases we've had, and I can't say that like we firmly feel one way or the other one if it should be proceeding. So in the doc, I'll just list the pros and cons we discussed, and then Tim, you could collapse that where you want to collapse it.
Cool.
I'm actually working on a just like a brief survey to try and get at like the really specific requirements of every use case. Yeah, I'm hoping I can send that out today. If you'd be interested in just like holding off and adding the use cases there, that would be great.
Yeah, that's fine. I mean, no problem. I'll look for that. And I know I had that to do, and Seth knows that we have that discussion internally. I just haven't synchronized the notes. So I'll look to get that in your doc, Tim.
Okay, so next week we come back to talk about that secure sandbox stuff, and Derek, are you the Sony is ready for the monitoring pipeline talk, because we scheduled that for last year, end of last year. We never have him come back.
Yeah, I would say we might want to strike that from the conversation for the time being. We're still trying to it's probably best for the moment that we get him off the agenda for the moment.
Okay, sure. Thank you. Okay, thank you for everyone for attending today's the Sig Node, and it's really good discussing, and looking forward for the virtual Kubernetes spec soon. Then we can start the more deep diving and discussing, and see you guys next time. Bye.
Actually, Don, before you drop, I think Mernal said he could present for Cryo next week, an update, so we can get.
Oh yes, we did ask last time, but yeah, somehow it's missing for today's agenda. Oh, that's good. So I will put it in the calendar agenda. Okay, thank you.
Everyone have a great day. Bye.
Bye.
Bye-bye.